Okay. See, the 24th class line, we started seeing about the waste reduction. Okay. So the waste reduction we'll call in the short word as a TIMBUL. Okay. Transportation, where your products are unnecessarily moving back and forth. Okay. And then the inventory, keeping the extra inventory. For example, car manufacturer keeping multiple car without booking. Okay. With the different models, which is not ordered by the customer. And not only that, it will get damaged because of that particular inventory. Maintenance is a bigger challenge, right? That one thing. And the motion, okay, the people is moving, and then access or process is moving here and there. That is called motion wasting. And then waiting for the equipment or people or process or end product from one place to other. These are all coming under waiting category. And overproduction, see, we are touching the account multiple times, okay, which is not necessarily for that particular process will be considered as a overproduction. Overprocessing, doing the same work again and again. For example, unnecessarily we are adding a process inside and then checking it. For example, log maintenance and all other thing. Okay, but the problem is the log maintenance is very important for our internal process. Okay, which is not a customer requirement, but our internal process maintenance, we are maintaining that. That's called the overprocessing. And defects, you know very well, that's an error by the particular team member. Okay. Yeah, this that particular slide. And next one, which we started as a what are all the tools we have to finish these kind of waste reduction, right? So if you see here, this is what we discuss on that 5S methodology. Okay, if you keep your things in a proper order, okay, it will reduce your time. For example, sort and then straighten the process, and then shine, clean the process, standardize your process like SOP and other thing, and sustain, and then maintain whether everything is right or not. Okay, that the way the 5S methodology is going to be helpful for you. And coming to the next lot, we have a Pokeyoki. Pokeyoki, nothing but it's a mistake proofing. Okay, the do the right at first time. Okay, that one. And then screening devices. Okay, there are some devices which will be check everything whether it is coming correctly or not. That is called your screening devices. And then signaling devices. For example, if a machine is shut down, the signal will be there. Okay, the signal will be available there to see them. And control device is to control your process, whether we are doing it correct or not. And then Kanban also we are doing the same way, which Kanban we already covered last time. Okay, this is a design of experiment we started last week. Okay, the design of experiment, for example, this will be useful whenever they are planning to do any new product. Okay, that's a design of experiment. When they are doing a design of experiment, they will do the screening. For screening, they may have the DOE. And for example, the type of experiments, if the main thing is based on the DOE, you can see that if you change some input, what is your output variable is changing. This is what I discuss on that particular thing. See, for example, you take the charge account. Okay, for example, you are getting a charge from 5 different pair. Okay, if one pair is charges are reducing, is it going to affect your output or not? That kind of analysis you can do using this DOE chart. Okay, so what are all the things we can do? Here is screening experiment. Okay, we have the multiple input variable. For example, I have 5 pair. Okay, that is my input variable. So by adding the 5 pair into your mini tab and check the output, okay, this will give a clarity on which particular input your output is getting majorly affected. That details you can identify by the screening. And optimizing the same thing. See, once you identify that particular input, say for example, I have 5 pair. In that, I am seeing that 8na is my major success. So what I need to do, I have to talk to my client, ask them to increase the patient visit for the 8na, which will improve my output. That is optimization, which will get it. And robustness experiment, it is mainly for a production unit. See, when they structure a design, for example, they are doing a mold. Okay, that mold should be very effective so that it can avoid the error. Okay, how we are going to use this in our method is, see, for example, we consider a process. Okay, we are getting a EOB to the SFTP process. Okay, from the SFTP, we are asked our team to go ahead and then post. See, the same thing for a charge entry, right? We are getting the encounter form, and then we are asking the team to go ahead and then enter the charge. So how we can improve the process, right? See, how we are making the mechanism, how we are tracking it, that and all, we can consider that as a robustness in the experiment. So wherever you are feeling that it is not coming right, then you can improve your process, and then you can improve the robustness of your particular experiment. And the type of experiment design is one factor at a time. See this here we discuss, right? For example, I have 5 payer and I'm considering my output, that's the income. So instead of that, here we are considering only one fact one time. For example, 8na alone, I'm checking what is my 8na input and what is my output. For example, BCBS is my input, what is my output. Like that we can segregate by one factor at a time. Or full factorial. Say I don't want to do one factor. For example, I'm putting all my 5 factors inside. So that is called your full factorial. Instead of that, I'm putting 2 to 3 pair alone. That is my fractional factorial. These are all, you can do it very easily by using your mini tab, which will be covered in your next certification. Okay, and what is the benefits here is we can be able to do the multiple factors at once. See, for example, you cannot understand the same way. For example, if you take a CPT code wise, okay, which CPT code is giving a better revenue by dollar value, you can understand, but many of the things it will give a clarity, right? By adding what you are going to get, what is your outcome. So this is very helpful. And second thing is very effective, very efficient and cost effective. You need not spend much of the time. It will immediately throw you the result there. Okay. And the third one is enable the analyze a large amount of data and construct a prediction model. See, for example, I have around 1 lakh data and how to analyze. These are all the DOE's benefit of it. Okay. Process of conducting DOE. So how I am going to run this DOE experiment. Okay. First thing, identify the objective. For example, my objective is I just want to understand which of my input is giving a major impact to my output. So that I'm taking a output objective as here, and define what is to be measured and show the results of the experiment. See here, what we are trying to measure here in our example, we are trying to measure our income, right? The collection, and identify the factors that are controlled during the experiment. Here, the factors are nothing but our payers, right? The input payers is our factors. And identify the set of level of the experiment must be considered. See here, when we do a mini tab DOE, we have 3 levels and then 4 level set of experiments will be there. From there we can do it. Okay, select the actual trial to take place. What do you want to do? Okay, how you want to start this particular process, and then perform a trial as planned. See, for example, you plan for a trial. Okay, how many trials you want to take? Same data, you run it for 3 times or 4 times to understand how the trials are running, and analyze the result and act on the result. This simply on the DOE, mainly to understand your output variable based on your input. We are using the DOE, and here
boss,
DOE we have.
I have one question here, boss. And for our process, which experiment will be better?
அதுதான் லேட் ஆகக்கூடாதுன்றது. இவ்வளோ நேரம் நம்மளோட ப்ராசஸ் தான் இவ்வளோ நேரம் வச்சு பேசணும், ரைட்டா? சி ஃபார் எக்ஸாம்பிள், I have a input. For example, 5 pair என்னோட இன்புட்ல இருக்கு. I just want to understand which input is giving a major impact on the output. For that only we are using the DOE. Okay. See, for example, the lab, we will take CRL lab. Okay. For example, I have around 10 or 12 pairs. So which pair is giving a major impact on my output? Which pair is not at all giving any impact on your output? That percentage and all other calculation we can do by one factor at a time. For example, one pair at a time, or all the pairs at a time, or
so
for example,
impact in the sense it is rejection and denials, right?
No, it's not a denial. See, for example, I see, we will take one more scenario. See, you have a CPT code, right? We will take MMTX. Your pseudoscan is a major revenue CPT code. You know that, right? But many of the process, we don't know what is the impacting input file, what we are going to put it into the process. So that clarity, the DOE will give you. For example, I have around 20 CPT code, or I have 100 CPT code in that particular input. Right. For example, you take one hospital. Okay, we have multiple CPT codes, right? See, when we are analyzing which is your output. Okay, for example, they are asking you to do an analysis and give a report to the hospital. Okay, how is this month payment should be? So by doing this kind of DOE analysis, by doing your input variable, you can give a clear-cut instruction to them saying that this month this particular CPT code is reducing, so this may give you the impact of 3% or 4% in your total revenue. Like that, you can give a clear-cut picture on them by doing this design of experiments. In our area.
So you meant to say that so it differs based on the project, right?
Yeah, it differs. See, what I'm saying is here we are considering what is the input versus output. That's what we are considering here now. Okay, that's what we are trying to do with your design of experiment. See, for example, I can improve my design of experiment to get better output. That's a way. And input you can improve on. See, for example, if it is a production floor, what they will do, they will first give the die, right? The die will be the basic material which is going to create a product. So in that scenario, they will improve the die measurement. Okay, that spec everything they will improve on, and they will give the variation they will reduce so that output can be given better way. So that's what they started. Now we are trying to fit that into our process. That's what the DOE. Any other question, anyone?
Got it, Eric. So, it makes sense, but it may be silly, but still, I would like to know. So, what would be the design of experiment that I have to choose for KCT and MMTX?
Yeah.
Because
see, actually,
this is our last class, I cannot pick it.
Yeah, actually, but I'm not able to explain you in a practical way. That's what you are not able to catch
Yes,
the 100%
yes.
of it. See,
Yes.
for example, there is a tab, one tool called mini tab. See, what do you need to do? You have to capture all your input. For example, input you take for a 6 months by pair wise. Okay, that is your input, and then capture your output. How we are doing it in the KPI report, right? The same way you upload the report for 4 months or 5 months. Okay, that's your standard one. And the 5th month, when you are giving only the input with five pair, it will throw you what is your impact on this particular pair. Okay, that's one is very simple standard method is there. Okay, I'm not able to explain. That's what you have.
Not a problem, Eric, but still,
Yeah.
I can get it. One last question.
Mm.
This design of experiments, in what frequency level on a monthly basis I have to take it?
What? Again, repeat
frequency. I mean, is it once in a week or maybe bi-weekly or once in a month I have to do this exercise?
Yeah, see, actually, when you are comparing the last month charges and then comparing this month, see, for example, we'll take a two scenario. One project, your M0 collection is more. For example, we will take one project where your AR days is around 18 days. In that scenario, you know very well that all our payment is going to be collected within that particular month. So in that particular project, every week you have to understand what is your inflow. So based on that, you can define your what is your output of it. For example, your AR days is around 30 to 45 days. So in that scenario, you have to take average of previous month and current month. Both you need to take. So this based on the project and based on how you are collecting M0, M1 and M2 trend. Based on that, you have to design your DOE.
Again, I'm sorry, Eric. So how this is going to impact in the improvement of any particular project?
Correct. See, for example, by doing a DOE, I have around 5 input payers. Okay. I know very well there are 2 payers are not at all giving any impact on my output. So I know very well. See, for example, we will take a scenario where the provider is out of network. We know very well it's not going to give any impact of my payment. See, for example, the provider may think that by doing an appeal or by doing for example, the patient may have that out of network benefit and I'm collecting it. That's what their assumption is. So when you're doing this particular experiment for 6 months or 8 months, the duration, then you can give them very clearly, you are not getting any patient with out of network benefit at all. So we can give a clear cut instruction with the data point. Don't take this particular insurance at all. That's the way we can close that.
That is perfect, Eric. So again, a last question.
Yeah.
Because let me shoot at my question. So are we doing this for last 1.5 years?
Are we doing these kind of experiments? Yes, we are doing. Yes.
Thank you, Eric.
Yeah. Okay.
That's all my question, Eric. Thank you.
Okay. We'll move to the next one. Okay. So the same DOE, we had given some other detail of it. Okay. So when we are doing any COE, there are some errors you have to aware of it, right? Whatever you are doing in the DOE, everything is not 100% perfect. There are 2 errors may come. One is systematic error. Second one is random error. Okay. Systematic error is nothing but it's happening in the instrument itself. Okay. Say for example, I told you very clearly, we don't have these kind of data recovery error will not be there for healthcare industry because everything is run by the system itself and we are getting it. For example, you are putting a manpower and then try to get a data, right? For example, we are asking the people to measure the height of the bottle. Okay, so it is not a machine, it's a man. So in that scenario, you know very well that by measuring the scale, okay, there is a defect will be available. That is called your systematic error by normally taken. Okay, the same error is evident every time the experiment is run. For example, every time if you run, that particular instrument is going to throw some error, that is called your systematic error. And random error is caused by unpredictable changes in the environment. Okay, for example, the temperature is increasing. Okay, your product is in expansion category. So that and all your random errors. And typically more of the environmental conditional changes will come under random errors. These two are not applicable for our industry. Okay, bias is nothing but it's based on the people. Okay, for example, the 2 or 3 people are taking it, there will be a difference in that. We'll call that as a bias. Okay, so to avoid these kind of things, we'll have a full factorial design. See here, small number of factors and levels. Okay, so instead of taking the whole as a one single segment, we will split that into small number of factor and then we will run it. Say for example, this is applicable only to your manufacturing industry. For example, if you take any of your product, they will mention as a batch number, right? Based on the batch, they will calculate all the quality and other things. So the batch is a smaller number which they are trying to give it. Okay, instead of full factorial entire process, they'll say that 1 o'clock to 2 o'clock will be considered as a one single batch and 2 to 3 will be considered as a second batch. So that kind of smaller number, they break it and then they will check that. Okay, more factors, there is a more cost and time is not an issue. Say for example, if you have a more factor, what you need to do, there is a cost and it involves a lot of cost and lot of time. Okay, where there is not an issue, they will go for a factorial. Otherwise, they will split into a small numbers. And fraction factorial design, this also use the same thing. When number runs in a larger due to the large number of factors and levels, still the extracted valuable information, but there with fewer run. For example, what they will do, we will take a scenario. Okay, the one factory is running for 10 hours to produce some products. So what they will do, they will not take the entire segment, but they will take any fraction, and then they will take, for example, I will take a sample 1 o'clock to 2 o'clock. What are all the samples has been generated? I will take that as a fraction, and then based on that, I will check this DOE. Okay, number of required rounds. Okay, see for example, whenever we take a sample, right? When we are asking our quality team to do a quality sample and then audit, we don't know how to finalize the number, right? So here there is a method, number of required rounds, if they will call that as a LK. Okay, where L is a number of level and K is a number of factors. Okay, this is a formula where to select the better design, but this will be applicable for the your production industry. Okay, and how to control the random error? See, we discussed the random error, right? Random error is unpredictable changes due to the experiment and environmental condition. See here, how to control it. One is balanced design. All the treatment combination have same number of observation. See, what we are trying to do here is we are doing a multiple sample and we are trying to get the same number of observation. See, for example, any outlier we are trying to skip it. Okay, for example, I am taking my spec, for example, 10 ml is my spec limit. Okay, one sample it is coming 20 ml or 30 ml, which is not at all relevant to that. We are discarded and then taking what are all the relevant to that particular experiment. Okay, and can set up the starting, define the level and number of factors, then calculate the runs required. See here, to control this, what we are doing is first we decide how many runs we are going to do, and based on that we can run. Okay, this is little bit hard to understand, so you have to relate that to your production unit, then only you can understand that. Okay, the randomization. See, for example, what we are trying to organize here is way to organize the order in which we are performing the runs. Okay, see, randomly you're selecting some sample to avoid these kind of random errors. Okay, so not only the batch, instead of batch, for example, 1 to 2, I'm taking 1 sample or 2 sample, and then 3 to 4, I'm taking 3 samples. Like that, I will take and then I will compare it and take an ordered sequence in the factor combinations. And treatment combination are preferred as a random manner, then improve the statistical variability. Mainly, this talk about your random sampling, how we are going to take a sample. And here the replication and repetition. See, when we are taking any DOE, you should know what is replication and what is repetition. Okay, replication is nothing but, again, we are reproducing. Say we are taking the measurement during the identical but very distinct run. So we are trying to create the same replication. Repetition is nothing but repeating the same measurement taking during the same run. See here, what you are trying to do here is, for example, 1 to 2. Okay, that is my batch run is is running. So I'm trying to take a sample, two sample, which will be the exact measurement. That's called your repetition. Replication is nothing but taking the measurement during the identical but a distinct run. For example, here I'm saying that within one run, I'm taking the same sample. Here, different run. For example, 1 to 2 and 3 to 4. I'm taking two different samples. That's called your replications. And the data entered is down to a single column. All the data we will calculate and then add it into a single column level. Here, no passage in time between the repeats. Okay, repeat will be done immediately. There is no time between. Here, as we said, we have 1 to 2 and then 3 to 4. There is a time gap is there. Okay, there is a time that passes between the first run and the second run. As I told you, 1 to 2 is your first run and 3 to 4 is your second run. So we are able to capture that variation. Here, we won't catch a variation because it's immediately running. There is no time gap difference between. Okay. Okay, main effects. There are type of effects. There's one chapter they had given. Main effect and the interaction effect. Main effects is a key factor that has been identified might impact the output. Okay, so we are trying to connect. Okay, what are all the things your output is going to affect? One is main effect, which is a very key factor, and interaction effect is between the two factor. That interactions is a part of the variation. Okay, these are all when you're taking the sample. Okay, these type of effects will come into a play. Okay, you just go through that. It's we don't have much impact on our process. You just go through this and then you will understand. Okay. Okay, here only we start very important process here. The cycle time reduction and all other things. Okay, case and blitz and all very, very important one. Okay, pay attention. We will see that what is that. Okay, so what is cycle time? So cycle time is from the start to end. What is the time it is taking to complete any of the process, which is called cycle time reduction. Okay, we have a two different time. One is called lead time. Second is called cycle time. Okay, what is lead time? Lead time starts when the request is made by the customer and end at the delivery. See, for example, we'll take one industry. Okay, see the customer is coming back and then he's ordering a car. Okay, when the order is given, that's your start. Okay, that's a lead time. When the request is made by the customer. Okay, so for example, I'm booking a car. So that's your lead time starts. And when it end, when the customer received that particular product, then it end. That's called your lead time. Okay, lead time is from the point to point, includes waiting as well as other delays. For example, I am booking today. My dealer is sending the request only tomorrow. That delay also includes in your lead time. Okay, everything, whatever is happening in between my booking to delivery, everything is coming in the lead time. Okay, lead time is measured in time, minutes, hours, and days. Okay, this is the way lead time is getting measured. So coming to cycle time, how the cycle time is differ. Cycle time starts when the work begin on the request and ends when the item is ready to delivery. See, for example, here is a different. Okay, when I booked it here as a lead time, cycle time when the factory receives that order. Okay, when the work begins, that's the time. And when they deliver. Okay, for example, the factories manufacture the car and then they're keeping ready to deliver. So that is called your cycle time. Now you understand, right? This between your lead time and the cycle time. Cycle time is nothing but if you take any process. For example, we will consider a charge entry. So charge entry here, when it will start, lead time is from when the doctor is signing the encounter form, and then from there the lead time start. The cycle time start when your people go to the SFTP folder and they started entering. There the cycle time starts. Okay, that's the difference between your lead time and the cycle time. Okay, cycle time is important because it has a major effect on the productivity. Say lead time, you cannot judge the productivity, but cycle time is a productive measure, right? When they took it, when they are completing it, that's your productivity. This leads to the organization competitiveness and market share. Okay, if your cycle time is lesser, you can give a better revenue or better share to the market. Okay, cycle time and lead time are different units of measurement. Cycle time is measured in a rate. Okay, so measurement is different. Here, as we said, time, minute, hour, and the days we are measuring. Here we are measuring by the rate. Okay, cycle time will be measured by rate. Rate in the sense it's a percentage kind of thing. Okay, what is your total time and how much time your particular process is taking? For example, 10% of the time my charge entry is taking, and 5% of my time the coding is taking. Like that, the cycle time will be defined based on your entire cycle. Okay, how to reduce the cycle time will benefits to you. Okay, see, mainly we have to focus on our cycle time. See, for example, I'll take one more example of a AR. Okay, see, I am touching the AR now, and then I am saying that claim is in process, and then after 30 days I'll go back and then check the claim in process, it is getting a denial, and then I'll start working on the denial, saying that it need to be appealed. Then I'm sending to appeal department is sending the claim. Okay, and the claim is sent to the payer, and payer is taking around 60 days. Now, so consider your cycle time. Cycle time, when you start, and then when it is getting delivered or it is paid, that is called your cycle time. So mainly you have to concentrate on how to reduce your cycle time. The length of the process need to be reduced by calculating your cycle time. So that's what we used to calculate. For example, multi-touch report, which is very helpful to reduce your cycle time. Okay, how many time a particular account has been touched by the user. Okay, for example, 4 times, 5 times a user is touching that account unnecessarily, that increase your cycle time, that need to be brought into a control. Okay, and then significant cost reduction. See, for example, if you touch the account and then it is getting paid, and you are doing a 5 follow-up and then getting paid, you understand that there is a cost reduction in it. So we free up some of the availability and we can increase our productivity. So for example, I have 100 accounts sitting unpaid. Okay, for example, my cycle time is reducing by 30. You can utilize the team very effectively. Okay, increase the quality and decrease the product time to the market. Okay, this is very important. So since we are not doing any marketing job, our product time, we are not understanding the importance of it. But product time is very, very important. When you get a charge, you should take very minimal time to send that to a payer. Okay, the same way, when the payer is not paying, our AR has to get that at the earliest, right? That's what the product time is. And translate to the quantifiable impact on the entire business. You see, the cycle time definitely impact your entire business. So you should understand what is the lead time and what is the cycle time. As operation people, we have to be more careful on reducing the cycle time. Okay, lead time may be the generalized statement. See, for example, your AR days. Okay, I'm saying that I'm taking 42 days as my AR days. That's your lead time. That's not a cycle time. Cycle time, it should be faster and it should be accurate compared to lead time and the cycle time. Any question here? Okay, we'll move on. So methods to cycle time reduction. Okay, what are all the things we can do? It's mostly, if you can think of any of the production unit. Okay, for example, mechanical production unit, you can remember or you can correlate what I'm trying to say. Okay, the continuous flow. There is an absence of interruption, problem, delays, and backlog within the process. Okay, so for example, a factory is trying to manufacture a product. Okay, from the input, it should come to an output without any interruption, problems, delays, and backlogs. If you consider that into your process, what is the interruptions? For example, software is not working, CR will not work today. That's your interruption. Your problem, your user is on leave. Delay, there is some clarification is not coming. Backlog, volume is more, like some projects, right? We are getting a volume, but we don't have a people to work on. These are all your continuous flow is getting affected. And more of the time-based methodology where the focus on reducing the defects by improving the logistics. Okay, so as we discussed, cycle time is nothing but we are mainly concentrating on the time it is taking to do, and customer will with minimal delay. Okay, so here we can say that it's a customer with a minimal delay. We can consider that how fast we are sending our claim to the insurance company, like reducing the lag days and other thing, right? Use of the units made up of the smallest logic level, either into one piece or smaller batch at a time. See, if you are not able to reduce your cycle time, what you need to do is break your process into a smaller unit and see that whether that particular batch is reaching there or not. Okay, this actually, what we'll do is whenever we have a very big projects, for example, 10 million or 15 million, the charges we are entering, right? In that scenario, what will happen is, say, entire team, if you put to do a charge entry, it will take a lot of time, right? So what we will do, we will break the process into a pair wise, right? One particular pair, one segment of the people will work, so they know the complete nuances of that particular pair, and then they will take care of that particular pair, and then they will start filing those claims. Okay, that's what the smallest logical level you can break, and then you can improve your cycle time reductions. Okay, right sizing batches is very important. See, for example, you should know how to right sizely you have to batch it. Okay, by experience you understand that. For example, I am working for a 15 million project, and each project will have how to divide that by the charge entry people, okay, or the pre-billing audit team or the quality auditor, how we are going to do this batch reduction. That will give a heads up on this particular thing. And setup production, see, if this is a continuous flow, okay, so by doing a continuous flow you can reduce your cycle time. The second one is setup production. See, what is this? Single minute exchange of dies, or SMED. This is very important concept actually. See, for example, I'll go by the production unit, and we will compare with healthcare. Okay, first thing is we'll go to the production unit. See, for example, the client is, or the customer is ordering, we'll take a water bottle. Okay, the water bottle of 1 feet and water bottle of we can say that 9 inches water bottle. Okay, 2 water bottle I need to produce. Okay, now my order is I'm producing continuously on the 1 feet water bottle. Per hour, my production rate is around 20 water bottle I am able to produce. See, all of a sudden I'm getting an order for 9 inches water bottle. Now they need around 1000. So what I need to do, I'm switching over from 1 feet to 9 inches. So for that, what I need to do, I have to change my die. So the die, by changing, it should not take much time. Okay, you should be able to change single minute exchange of dies. Okay, within a minute you should be able to change your die, and then from 1 feet you should be able to produce your 9 inches production. Okay, that's called your single minute exchange of dies, which is called SMED. This very powerful methodology which is used in the lean. Okay, so how we are going to use this here? See, for example, I have a 2 user here. Okay, one user know only the project A. Okay, we'll consider, for example, one project is very delay. Okay, it will not come regularly. All of a sudden it will bump. For example, IMA we will take. Okay, weekly, 1 day only it will come. On all other day the user has to sit idle without any work. So how we are training them? So we are allotting them or training them into a different process, ask them to work on the process. See, for example, we'll take A. Okay, project A, we have only requirement is very less, but we are adding one more person to process A, and then we will ask our user to start the project A. Whenever the IMA project is coming in as with the bulk, what we'll do, we will take the project A people also to the IMA and then ask them to work. See, that's called your single minute exchange. So the person should be capable enough for 2 or 3 projects. Whenever there is a requirement is there, you can switch over to the next one. So this is, we are considering this as a SMED. So don't keep your people ideal for only one project, especially what our setup is, very smaller projects, right? So the SMED will be the very capable process you can implement here. So that's a reason when you are taking any of the projects, right? 3 or 4 projects, your people, set of people should know the 3 or 4 projects. That's called your single minute exchange. Okay, and the product diversification means we need the product smaller batches change over more frequently. That's what. See, you have 10 batches in one particular project. You can allocate each project to each batch to one person and then ask them to complete. The same way, they should be capable enough to handle the different clients at the same time. This is called SMED. Okay, what is the benefit of setup reduction? Flexible enough, and it is lower to cost and increase the capacity. With the existing people you can utilize and reduces your lead time, right? Additional people can be pushed in whenever your inflow is more. The SMED process organize the setup operation. So this is, you have to organize your setup. Okay, how your team is going to work, especially the charge entry and payment posting. This SMED is a very powerful one. You should know how to utilize the people on SMED and outline each step that require for a setup. Okay, so here, what is the challenge here? For example, I'm using one person into 3 different projects. They should know the spec of it, right? They should know the specification of that particular project or SOP of the project. Otherwise, they will create a lot of error. So we have to train the people in such a way that it can be single minute exchange. They can go to some other project They should know the SOP and then they can start on. Okay. So the people knowing the SOP or people knowing that spec of the project is nothing but it's similar to your changing the die of any of the production. Okay. Know where the waste is within the process. Okay. For example, if you are not able to use the people and that is your waste, and second time when the input inflow is not regular and you are keeping additional people, that will be your waste. And then convert internal to the external. For example, internal, whatever the challenges you are facing here in the internal, you can bring it to external and you can discuss with the management and to the client, and then to that you can streamline your process. So the frequent changes can be avoided, or if it is necessary, we will train the people or train the internal to take it up. Okay, improve the internal setup, have documentation. This is very important, right? So the documentation is nothing but our SOPs, right? And how to go about performing the changeover, SOPs and standard of work. So when a person is trained on 2 or 3 projects, there is a risk mitigation involved, because the people may tend to implement the previous project SOP to the new project. That's one major challenge which we have to be very, very careful in taking care of it. Okay, that's one thing. Any question here? SMED is very powerful. Okay, you should understand SMED. Okay, I'll move to the next one. Okay, here the Kaizen and Kaizen Blitz. Okay, you should know the difference between Kaizen and Kaizen Blitz. What is Kaizen? Every day you have to bring some improvement in your process. That is called Kaizen. Okay, it's not all of a sudden nothing is going to change.